Hi and welcome to Comprehensive Tutorials. In today's video, as we mentioned in the previous video, we will be looking at constant objects of a class. And to do this, we will be using our vector class that we defined the other time in a previous video. But for new viewers who will be joining us, let's quickly do a quick recap on what we have done, because I assume that such a viewer who is interested in constant objects might have known how to construct a class in the first place. So let's quickly go over that. Now we have an include IO streamline over here, and which is just the normal line that we include in our C++ programs. And the normal line over here as well is not normal, it's just specific to this environment. If you are in Visual Studio or PyCharm or any other editor, you don't need this line. This is just for code blocks. And if you're in code blocks and your environment is not set up like this, you don't need this line as well. If you are an old viewer, you can skip ahead to the start of the video, to the topic for the day. Now we have this line over here, which I assume you know. We have the constants over here to use new line to denote a new line in T for a tab. Now to our class vector. So this class allows us to create objects in this format, just like the mathematical representation 4-5 as such. And as we can see, we have X component and a Y component. So the attributes over here allow us to give X component and Y component to our objects. Right. Now we have a constructor over here, and this one just allows us to create an empty vector and then assign values to it later. And we have a second constructor here. We use the member initialization to allow us to pass attributes during the point of construction. Now we have the first method here, void print, which just allows us to output the components, and we have the set attributes here. I think we will not be using it in this tutorial, so you can just forget about it. This was only necessary when we're making the tutorial for the this keyword. So to do this, let me just go ahead and then I think let me just leave it there, but I will not be using it. Don't mind if you don't understand it, just forget about it. Right. Now the next thing was to have our void classes to function, and now this function is my int main function. So the normal thing is you run your code in your int main function, but for this environment I'll be running it from classes to function. So every code that I will be running here, I will be writing here, please write it to your int main function, is going to perform the same thing perfectly. And any code I will be writing outside here, just like this, you write it outside of your int main function. The results are the same. Now these comments here are just the outline of this particular video. You can see there are a lot over here. I don't want to miss anything, and I don't want to appear disorganized. I want to go in a way that will be understandable. Right, so now let's just get to it. So the topic for today is constant objects. What is an object in the first place, and what is a constant object? Now we have our class vector, and to create an object, let's say this object is called vect1, and we want to give attribute to it like 3 and 5, right? And then we can go ahead and then print this particular attribute. So dot, when we put the dot operator, we can see those methods and attributes that we can access. So we just want to use the print, and this will get us the components in a mathematical representation, right? So we are running this, and we have 3 and 5 appearing and output as a mathematical format. Now what we can do is, even though we have passed in 3 over here, we can reassign it. So let's just say that it was 3 over here. So let's just say that vect1 dot, then we reassign the X component to be 67. We go ahead and run this, and let's see what the output is going to be. Now we have the X component updated to 67 over here. So this allows us to update the components. But then what happens when we add a constant keyword over here? Let's look at the functionality. What happens when we add a constant keyword here? Now we run this to see what happens, and then we explain further. Now we can see over here that the assignment of member vector A is read only. Now what you should notice is that constant members are only read only. To explain this concept, I would just compare it to the normal one that we know. So we have int A is equal to 5, And when we try to update a to now be 5, let's say plus, or let's say just say a plus 5, it will run and be updated. But when we make this a constant, then we cannot update a. Is going to return an error. You can do that and see. So when we have a constant object, what that means is that the attributes over here of the object are constant as well. So we cannot change them because those attributes are now constant. So that's why we have the error over here, and so we cannot change it. Now the second thing to note is that when we have this particular constant object and we go ahead to call its non-constant methods, so we have the dot operator over here and we are trying to access some of these methods. So let's call the print to just output the components of the vector. So we are running this and we have an error. I think it's because of the semicolon. So let's run this again, and now we still have an error. It says that passing constant vector as this argument discuss disqualifies. Right, so over here, what in essence is that we cannot access the non-constant members of the class. Now this is a constant object and this is a non-constant method. Over here is a non-constant method, but this is a constant object. So what it's saying is that we cannot use a constant object, cannot access a non-constant method. To be able to access it, we have to make this particular method a constant as well. So to do this, to make a method a constant, what we have to do is to come between the parenthesis and the curly bracket over here and put in the constant keyword as such, and then the print method becomes a constant. And we will see that in later videos a constant method can be accessed by a constant object and a non-constant object. But for now, this is a constant method and then this is a constant object. So then we can run the constant object dot a constant method and it will give us an output. So then we have the 3, 5 over here, which is the components of the constant object vector 1. So two things now. A constant object has constant attributes. A constant object can only access constant methods. Great. Now the next thing to look at is the various forms of this, using this constant keyword with the methods. Now the first thing to note is that, let's say this is our constant void print, so we have it over here, void print, constant cout and all of that. So I just shortened it over here. Let me go ahead and do this. So this is what we're talking about. To make this method a constant, you just put in the constant keyword over here as we have done. So we have void print parenthesis constant and all of that. So we come over here, void print parenthesis constant, all of that. Great, I hope you're with me. Now the next thing to note is if the constant keyword is between the parenthesis and the curly bracket, what that means is that we are only making the method a constant. We are making it compatible with constant objects. So constant objects can call it. But when we clear this constant keyword and put it here and put it over here, what that means is that, let me clear this, just like this format. So we have constant int and we have this address of operator over here. Now when it's over here, what that means is that the member function returning value of this method is a constant, right? So you cannot change it. We have looked at passing parameters as constants, as values, and as pointers, and we have looked at it advantages and disadvantages in a previous video. So this particular method will be returning a constant reference. Please, you can watch a previous video for that, but we're only looking at the syntax over here and what it means. Now the third case is when we have constant at the beginning of a method and then constant keyword over here as well, two constants. Now, what does that mean? What that means is that in the first place, it makes the method compatible with constant objects, and then it makes whatever that function is returning a constant, but then a reference to another value. Now, what we want to look at is this concept that constant functions cannot modify non-static data members. To illustrate this concept, I would go ahead and then create a static variable. Right, so now these are non-static members. Float x is a non-static member, float y is a non-static member. To create a static member, let's just have int z. Int z is just a variable, and to make this static and to link it with a class vector, what we have to do here is to use the class vector with the scope operator to link this, and we have to initialize it, let's say probably to 56 or anything. Then we get in here and then we say that this particular attribute is public. It's public over here. So we are putting under the public domain, and we are saying that it's a static, let's say float. I think I should have used a float z. Right. So let's make this a float. Sorry, I'm very sorry about that. Right. So we have float vector z, and we are initializing it to 56. And then we have over here, we are making it static over here. So static float z. Now what this means is that it's accessible to all the members, and it's in essence called a class variable. I will not go into the details. We have done that in a previous video. So I'll go ahead and just build on it. So now we have print over here, and what we want to do is to modify this to output the components of a vector object to include the z. So what I will be doing here is to add the z component. So a comma over here, and then the z component as such, and then the closing parenthesis. So now the z will be output when we call the print statement. To get what I'm saying, let's go ahead and illustrate this concept. Right, so now we have a constant vector created using this constructor, a constructor which accepts just two values, a and b, and it assigns them to the x and y components. And we have z initialized to be 56. So every object over here using the class vector has a component called z, which is initialized to 56. Note that. Now then, after we created this, we are coming down to print the components.print, right? And then we run this to see what the components of vector 1 will be. Now we have 3, 5, and 56. So the 3 and 5 are the values we passed over here, and then the 56 is the static variable that we have initialized over here. So we just added it here to be printed just like a three-dimensional vector. Right. So when we have a second object like vector 2 and we print its components, the z component is going to be 56 as well. But that's not the focus of this video. What we want to illustrate is that constant functions cannot modify non-static data members. To illustrate this, let's create a constant function to modify a member. Let's call this float. So we are trying to create a constant function, and we want to call it modify add, and you see why in a bit. And this is going to be a constant, and then what we want this particular function to do is to try to modify the x component. So we want to say the new x component is equal to x plus 3, and then we want to just return x. Right, so we have a constant function here called, a constant method here called modify add, and what this method is going to do is to try to modify the non-static member x, and it's going to return the x. So let's run this to see if it will give us any compile time error. So we have a compile time error over here. It says that assignment of member vector x in read-only object. Right, so what we have over here, as we have mentioned, is that a constant object has constant attributes. So what we are attempting to do over here is to reassign a constant attribute, which is not possible. So then let's try to reassign the z component and return z. So let's run this to see if we will get any error before we try to do anything. Right, so we are past compile time and we don't have any error. The output we have over here is just because we are printing the vector 1. So we close this. Now to see whether the z component has been updated, let's go ahead and then call the vect1 dot modify so that the z component will be modified, and then after that we want to print vect1 dot print to see what the output is. So let's have it here to see the values before the modification, and then we have it over here as well to see the values after the modification. So we go ahead and run this, and now we have the value of z before the modification to be 56, and that's the value over here. And then we have the value after the modification to be 59. Great, so we can see that it's been modified. So the statement that constant functions cannot modify non-static data members has been shown, and it's true. Now we'll go ahead and illustrate the fact that constant functions cannot call non-constant functions, non-constant member functions. So how can we illustrate this concept? To do that, let us try to create another constant member function to try to call this constant member function. Right, so what I thought was that we should have what did I write down here to do this? Create a print z method to print the z component. Right, so what we want to do is to just try to print the z component. So we want to have a void because we will not be returning anything. So void, we want to call this print z, and this is not going to take anything over here, but then we want to make it a constant because we want to test the fact that constant methods can only call other constant methods. So we are making this a constant, and what this is supposed to do is to just see out the z component, right? But then to see out the z component, we use this keyword over here to ensure that an object created here, okay, I'll explain later. So this is a pointer, and we can use not the dot operator, we should use the arrow operator. So this gives us access to all of the things we can do with that. So we want to print the modify add, and then after that we want to have parentheses, sorry, the semicolon. So when we come down and then let's say we call vect1 dot print z, then what this will do is that in place of this, it will get the pointer for vector1 or vector1, and then call the modify add, which is again a constant function. So the fact that we are trying to illustrate here is that constant member functions can only call constant member function. So modify add is a constant member function, and print z again is a constant member function. So let's see if we can do this. So to illustrate this, let's go ahead and clear this. And so we have a constant object, and we are trying to say that vect1 dot print z, right? Let's see if this will work. So this will just print the z component of because this over here is going to replace by the pointer for vector1. Let's run this, and now we have 59. So what happened was that when we called vect1 dot print z, it called the print z constant method. In the first place, vect1 is a constant, print z is a constant, so they are compatible. Then after that, it came over here and called this print z. And what does this print z do? This print z will just get in here, and then whatever the pointer for object 1 is, that pointer arrow modify add, and modify add over here is a constant. So it takes that and then updates the z component of vector 1, and then it outputs that. So that's what happened over here. Now to test the other way around, let's say that we are trying to call this constant function on a non-constant method. So we have to have a non-constant method in order to be able to illustrate this. So let's have a second method called modify sub to be modify subtract, and you see why in a bit. And so we are not making this constant because we are trying to test the opposite. So what this would do is to take a z and then is going to subtract 3 from the z. So the z would be updated to z minus 3, and then what we want to do is to return z. So we are not doing anything here much. What we are only doing is that we are making this a non-constant, and then we want to get in here and then call the sub. So this is what we are testing. We are trying to see if we can call a constant method on a non-constant method. So let's go ahead and then call out this. Note vector1 is a constant and print z is a constant as well. So let's see if this will even run. And now we have an error. It says that passing constant vector as this argument discards, qualifies, and all of that. So we cannot call a constant method on a non-constant. Now what happens is that when we call the vector1.print z, this is a constant, so they are compatible. But then when it comes in here, it tries to modify the z component, right? And when you call, let's say, vector1.modify sub, this modify sub is not a constant. So this over here, there is this contradiction, a constant with a non-constant, which is a contradiction. So what we can do over here to make sure they are compatible is to have the constant over here, and then the z component will now be updated to 56 minus 3, and that's going to be what? 53. So we should be expecting a 53 over here. Great. So we have successfully illustrated our concept. Let's clear this. Just leave it like that. Now what we want to do is so we have done this. Now constant objects can only access constant functions, which we have already illustrated that when you have a constant object, you cannot access non-constant methods. So for example, we cannot have, when we had no constant over here, we saw that it threw an error, and so we have already talked about that. Now the next thing we want to do is to show that non-constant objects can access all functions. So when you have a non-constant object, for example, we have vector and vector2, right? And let's say that we are passing in 5 and 6 over there. This is a non-constant object, but this is a constant object, right? So let's go ahead and say we want to get vect2 dot I don't know what we should do with this. Let's just say we are printing the z and see what's going to happen. So we run this and we have passing constant vector as this argument and all of that. So what we have over here is still the sub. So let's say that we have the add. Because the sub is a non-constant, the constant method cannot call a non-constant method. So what we now have here is a constant method calling a constant, another constant method, because modify add is a constant. So what we want to illustrate, so with that error cleared, what we want to illustrate is that a non-constant object can call constant method. Print z is a constant. So let's see if that's going to work now. We run this. And now we have 59 as well, because z was set to 56 and then we called print z. So what print z would do is it would pick the pointer for vector 2 and then get the method called modify add. And when we call that method called modify add, what modify add will do is that it will add 3 to 56, which was the z component, and that would be 59. Great. So we can see that vector2 dot print z, which is a constant, works. Let's see whether vector2 dot print would work as well. So let's close this and run. So we have 5, 6, 56. So the 5, 6 is the components that we passed over here, and then the 56 is the initialized value for the z component, and the print over here is just calling this one, which will just print the components. We have not modified it yet because we have not called any dot vector2 dot modify. We have not done that, so that's why we have 56 over there. Now the next thing I want to look at is, so we have looked at non-constant objects can access all functions. Now overloading member functions. To do this, I would want to use a third. I think we would be adding 2 more methods. I don't know if I should clear all of this to create space. Okay, so I'll be clearing all of this. So I'm clearing it up to here. Great. So now I'll be having 2 more methods. So the first one is going to be called, I think we should just name it, yeah, float norm. And what this norm is supposed to do is to get the magnitude of the vector. So what I mean by the magnitude of the vector is how the size of the vector, right? So we have a vector like let's pick 3 and then 4, right? So what this will be doing is that, so when you have a vector like 3 4, so when we have a vector like 3 4 on the Cartesian plane, let's say this is the Cartesian plane and this is the x-axis and this is the y-axis. So 3 4 would be 3 on the x-axis and 4 on the y-axis. So let's say this is it, and this is going to be the point over here, like that. So we have a vector like this. Now the norm over here calculates the magnitude, and it's the x component squared plus the y component squared, all square roots. So this is the norm over here. You can say it's the Euclidean norm, right? But that's not what we're looking at. All we're interested in is to compute this norm over there. So we'll be squaring the x component, and then we'll be squaring the y component, and then square rooting that to give us the norm. So that's what we are coming to do over here. So to do this, we would be including this line to allow us to do that. So we would be including math.h to allow us to use the square root and the exponent. To do this, we'll be creating a variable to store the norm. So we would want to have double norm, and we want to say that this should be the square root of whatever computation that we are going to be making. So we would have the power, we'll use the power again, and to be able to use this, you must have included the include math h line over there. So now what this means is that we have x to the power 2. So the first one is your base, and then the second number is the power that you're raising to. So this means that x squared. Then we are adding that to the power of y. So we are adding that to y power 2. That's what this means as well. And then after that, we are taking the square root of all of that. Let's not forget our semicolon. So we have our norm over there. Now, okay, let's go ahead and make this a float to be compatible with everything. So we have a float. Now the next thing we want to do is to see out the constant norm is norm. Then we should have a new line in case of anything. Right. Now the next thing I want to do is to copy this and then paste it down here to have 2 norms. But then this is not going to be a constant, and we'll get in and say that the norm is the x squared plus y squared all square root. And now we just want to say the normal, or let's say the non-constant norm is that. So we have 2 norm methods. One is a constant and one is a non-constant. They are doing the same thing anyway. The concept we want to illustrate here is that when we have 2 objects, one is a constant and one is a non-constant. When we just say, so now we are saying that vect1 dot norm. You see that there's just one norm here because both of their names are norm, right? So we have vect1 dot norm as such. Let's print this and see what is going to happen. Now we have the constant norm is 5.83095. You can go ahead and find the square root of I think is, where is it, of 3 squared plus 5 squared, right? You can and verify this answer. But what we want, the focus of this particular section is that a constant object calls a constant function. So we had the same name, norm, norm, float, float, but this object was constant, and because we called the norm, the computer called the norm version, the constant version of the norm. Let's go ahead and call vect2, which is a non-constant, dot the same norm to see which one will be output. So we run this. So we still have this open. So let's go ahead and close it. And then we are running this now. And we have the constant norm is that why was vec2.norm, why wasn't it not called? Okay, let's add this line that it should return float. I'm very sorry about that. And we add over here return norm. Sorry, return norm. Let's rerun this. Now we have the constant norm is 5.8 whatever, and the non-constant norm is this. So the second line, vector2, remember, was a non-constant, and so calling this, the computer went ahead to call the non-constant form. That's why we had this line output over here. But then vector1 called this one. That's why we had the constant norm output over here as well. So that's what we call function overloading member functions. When you have one as a constant and the other as a constant and the other as a non-constant, even though they have the same names, they will be called with respect to the state of the objects. Right, now most program functions take class objects as whatever. So what we want to illustrate over here, I think is the last one, is that let's say we have a normal function over here. Remember, I'm just creating a normal function called, what did I call it here? I called it get norm. Right, so we have a normal function here called, so this is just going to return a value. Sorry, it's just going to output a value, so we are not returning anything. So we are calling it get norm, right? And then what we want to accept as a parameter here is a constant vector, and we are passing this by reference. Let's call this vector A, we can call it B, anything. Right, now what we want to do over here is to call, so whatever vector that we are passing over here, we want to say that vector dot get the norm, right? Dot get the norm, and the norm is going to get this, any of these. Now we would explain after we run this. So then we have created, we'll clear this. So what we just did was to create a normal function which is going to take a vector, and it's a constant, and it would print the norm of that particular vector. Let's add parentheses here because it's a method. Great. Then we came ahead to create two objects of the class vector. One is a constant, the other is a non-constant, and then we are calling the get norm on that particular object. So let's call the get norm on vect1 to see what is going to happen. So we are running this. Okay, I think this thing is still open, so I'll close it, and we are running this again. And now we have the constant norm is 5.8. Why was the constant norm called? Because A is a constant object, so it went ahead for the constant one. Let's pass in vector2 and see what happens. The constant norm is that. Why did that happen? To see the difference, let's print it 2 times. So let's call the get norm for vector1, and then we call get norm on vector2. Remember when we just did vector1 dot norm and vector2 dot norm. Okay, I think we should do it this way so that you guys would understand what I'm talking about. Vector1 dot norm, and then vec2 dot norm. Before that, we want to output cout normal call, and then we want to cout get norm call. Then after that, a new line. Right, so let's just go ahead and then make it presentable. Right, let's run this and we'll explain after the output. Now we have normal call returning the constant norm is 5 point whatever and the non-constant. So when we just called them normally, remember vector 1 is a constant, so calling it on the norm got the constant version, and vector 2 is a non-constant, so calling it normally just went ahead to get the non-constant version of vector 2 of the method norm. But then what we wanted to illustrate here is that most program functions take class objects as constant references, so they can only access those constant methods. So when we have a function which is accepting a constant version of the reference form of an object, okay, so let's just say that we have a function which is accepting a vector, and that vector object is a constant, right? In simple terms. Now this function over here, whether the object passed here is a constant or a non-constant, this function over here will always go for the constant versions and never the non-constants. So that's why we ran it over here, and then we had, so when we call the get norm will always go for the constant versions and not the non-constant. Note here that vector 2 is a non-constant, but again, because the function is accepting constant objects, it went ahead for the constant. So that's why we have the constant norm is that, and the constant norm is that, even though we have the same values because the functionality is the same, but then the print statements here will tell us which one was called. Right. This was an exhaustive video, I must admit, and I hope that you understood what I was saying, and I hope that this structure laid out here presented things in a way that will be understandable. Right, so if you would like more information, there is always more on the official C++ website, and that's over here where we have the constant member functions, and this is what I tried to illustrate in that video. You can come here for more information if you want to. Now the next thing we'll be looking at is what we call class templates. Until then, stay safe, have fun with the program. You can go ahead and experiment with all of these and leave comment in the comment section on what you have found, so we all learn from you. Right, see you.